Back in 2017, Australia started a megaproject aimed to build upon the base created by the original Snowy scheme. This project, named the Snowy 2.0, started with the vision to greatly increase Australia's energy production and had a budget of $1.5 billion. But even though we know estimates aren't accurate, it's still crazy how the costs associated with the project have inflated to a staggering $8 billion today. From delays to technical issues to geological issues, there have been numerous hurdles that the Snowy 2.0 has had to face. So, why has this project become so expensive, and why is it so challenging to complete? Let's find out. Please make sure to support our channel by clicking the like button and following us so you won't miss any updates on the latest mega projects. The Snowy Mountains scheme was completed in 1974 and featured 16 dams, 8 power stations, and 2 pumping stations. It also has a wide network of tunnels and aqueducts that cover 225 kilometers, 140 miles. This made it a marvel of engineering and the largest engineering project in Australia. It has helped Australian energy production and irrigation for decades since it was built. Now, the Snowy 2.0 megaproject aims to increase the grid by around 2,200 megawatts and store 350,000 megawatt hours of energy. Effectively speaking, such an expansion would transform the original system into a massive battery. And this battery would have enough energy to power up 3 million homes for almost an entire week. To put that into perspective, the project could create enough electricity to power up a city with an area of around 12,000 square kilometers, 7,500 square miles. These numbers are staggering and show just how big of a potential this project has. The project was designed to have a price tag of $1.5 billion, which makes sense due to the benefits it could provide. The underground power station will be huge and buried 800 meters, approximately 2,600 feet, beneath the surface. This power station is planned to connect 2 existing reservoirs using a network of tunnels that span a length of 27 kilometers, 16.8 miles. These reservoirs, Tantangara and Talbingo, sit at different elevations, which are perfect conditions for pumped hydro storage. Water is pumped uphill from the lower Talbingo reservoir to the higher Tantangara when there's excess energy from sources like wind and solar. Subsequently, when the energy demand reaches its peak, the water is released back downhill, which turns the turbines and allows it to generate electricity. To expand the existing Snowy Mountains hydroelectric scheme, construction has been divided into 5 phases. Phase 1, which includes essential exploratory works, involves drilling an exploratory tunnel, modernizing site access roads, and setting up barge infrastructure on the Talbingo reservoir. But the real heavy lifting begins with the tunneling. The project requires more than just any ordinary excavation to the geology of the area. Some of the most advanced tunneling technology in the world is being used to proceed with the project. This includes 3 tunnel boring machines, let's shorten it to TBMs, which would be responsible for creating the large underground network of tunnels. These machines are engineered marvels. As an example, TBM Kirsten is one of the longest in the world at an astounding 210 meters, 689 feet. It also weighs a hefty 3,300 tons. This TBM isn't just large, it's also highly specialized for the job. Designed to excavate at a steep upward incline, TBM Kirsten employs a cutting-edge coupling system to reinforce the interlocking concrete segments that line the tunnels. To ensure the integrity of the tunnel and the machine, a process known as grouting is employed. This involves injecting grout ahead of the excavation to solidify weak ground areas and limit water infiltration, ensuring the TBMs can work efficiently without the risk of the walls collapsing or groundwater flooding. These machines aren't just drilling at a single level either. TBM Kirsten will soon begin working on one of the most challenging aspects, a steeply inclined pressure shaft. Imagine a tunnel climbing upward at a 25-degree angle, while the machine itself undergoes modifications to ensure it can keep working safely and efficiently. From altering the TBM's tanks and mechanical equipment to stabilizing the machine as it crawls uphill, every inch of progress in this section is a feat of modern engineering. The tunneling work also includes the excavation of multiple cross tunnels that connect the emergency, cable, and ventilation tunnels. In fact, TBM Kirsten has already tunneled 2.8 kilometers, 1.7 miles, providing access to the underground power station cavern complex, which is among the largest and deepest of its kind in the world. In parallel, TBM Lady Eileen Hudson completed the 2.7 kilometer, approximately 1.7 miles, main access tunnel and will soon begin excavating the 6 kilometer, 3.7 mile tail race tunnel, a key component that will connect to the Talbingo Reservoir. All of these excavation activities, whether it's boring the inclined pressure shaft or drilling cross tunnels, are just the start. Snowy 2.0 also requires the construction of intake outlet structures, a big surge shaft and excavation of intakes at Talbingo and Tantangara. It's a highly complex project, and each of the challenges presented during the construction add to the cost. As we mentioned before, the budget for this mega project was set at $1.5 billion when it was announced. That would have been a bearable number, but that number quickly ballooned to $3 billion by 2018. And right now, the costs have inflated to a whopping $8 billion with no certainty that it will remain at this figure. So, why is the project so expensive? One of the most significant challenges is the unpredictable geology of the Snowy Mountains. The complex and abrasive rock formations have caused numerous setbacks. In 2022, the TBM Florence hit soft soil just 70 meters, 230 feet, into its journey, which caused a 9-meter, 29.5 feet, sinkhole to form and halted progress for a year. Even after Florence resumed work, progress remained painstakingly slow due to the tough conditions underground. Florence's stalling added months of delay and millions to the overall cost. The observational approach used during the project, where designs were adjusted in real time as engineers encountered unforeseen conditions, led to further delays and increased costs. One of the ways engineers are trying to mitigate these issues is through advanced 3D modeling of the underground geology. But the process of building these models hasn't exactly been easy. Even with the techniques being used, it's still pretty complicated due to the geology of the area. With such massive machines being used, every delay leads to more expenses. The costs to maintain the equipment and to pay the workers add up each day. And the pandemic was the cherry on top as it caused material shortages and a lack of skilled labor, which resulted in procurement being done at higher prices. While the idea of Snowy 2.0 seems simple on paper, the technological execution is proving to be anything but. The main challenge is that Australia is attempting something at an unprecedented scale. Pumped hydro projects exist elsewhere, but none are as ambitious as Snowy 2.0. So, with these technical and financial challenges, the question remains, will Snowy 2.0 be successful? It's difficult to say in all honesty. The delays and the increases in cost are not as easy to ignore. Some analysts have even asked whether Snowy 2.0 was even a wise investment at this point due to the improvements in battery storage technology. The tech has improved to the point where it can be seen as more environmentally friendly and cost-effective as compared to pumped hydro energy. For example, Tesla's battery systems in South Australia have worked pretty well to stabilize the electricity grid. And the battery systems don't require massive upfront costs, and neither do they cause environmental damage in the way that mega projects like Snowy 2.0 cause. Worst part is, the date for completion of the project has been pushed back to 2027. And it might be pushed back even more. If this continues to happen, there's a major risk that the project might become outdated even before its completion. Everything aside though, there's no question that Snowy 2.0 has massive potential to store and supply renewable energy. If the project works and is completed without becoming outdated, it would help reduce Australia's reliance on fossil fuels. At the same time, it would continue to power millions of homes, even when solar and wind energy aren't generating energy at full capacity. So, Even though the project faces considerable risks, there's still optimism that it could deliver significant benefits. So, will Snowy 2.0 be a game changer for renewable energy in Australia? Or a cautionary tale of technological ambition gone wrong? Let us know what you think in the comments below. And don't forget to like, share, and subscribe to our channel.